Hi, I hope that you are having a great time at SQL Bits Online. My name is Mladen Andzic. I'm a program manager on Azure SQL team, focusing on Azure SQL Managed Instance. I'm really glad to be here with you today and talk about Failover Groups. We will be focusing on SQL Managed Instance case with the Failover Groups. However, there are just a few differences in Failover Group properties between Managed Instance and SQL Database, and I will talk about those small differences. So we will start with sharing a couple of facts about Failover Groups really quickly to build the context. Then we will go through the Failover Group architecture, going step by step through the creation of the Failover Group. And at the end, I'm going to share a couple of very interesting and important points and cases from the experience working with customers so far. So, as you know, Failover Groups are a top disaster recovery solution in Azure SQL for most demanding business critical applications that have to survive region-wide failovers and continue working in a very short time. So Failover Groups work over different regions only, meaning that two instances connected into a Failover Group must reside in different regions. That could be like any two regions, Azure regions. However, what we strongly suggest is to use regions that are geo-paired. So basically there is a concept of geo-paired regions in Azure SQL. So we are taking care that from the any geo-pair at any moment we are doing any planned maintenance events only in one of those two regions. So it's really important to understand that due to the fact that Failover Groups work across different regions, they use asynchronous application, which means that a certain data loss is still possible with Failover Groups. The recovery point objective, RPO, of Azure SQL is both for SQL Database and Managed Instance is 5 seconds. Still, there is a way to achieve RPO of 0, meaning to avoid any data loss with the Failover Groups. Of course, it comes with a trade-off in terms of the performance. So basically, if you call store procedure spwait for database copy sync after committing each transaction that must be hardened on the geosecondary, you will wait longer. However, you will have a guarantee that there will be no data loss in case of the regional failover. So Failover Groups require that both instances have same service tier and even same storage size. However, compute size may be different between primary and secondary. However, note that there is a throttling mechanism. So basically, if geosecondary, which has a smaller amount of resources available, for example, cannot catch up with the primary, it will throttle the workload on the primary, meaning that you should be really careful when deciding to downsize your geosecondary. All user databases are replicated in the case of Failover Group with a managed instance. With Azure SQL Database, you can pick any subset of your SQL databases for Failover Groups, and also you can establish multiple Failover Groups for a single SQL database. That's not the case with the managed instance. It's precisely two managed instances in a single Failover Group, and single managed instance can participate only in one Failover Group. Another important fact is that system databases are not replicated with the Failover Groups. It has some repercussions on logins, agent jobs, service master key, and we are going to cover that during the presentation. So let's jump into the architecture of the Failover Group. We are starting from the almost blank canvas, but we are going to draw a lot here. So what we have here is two empty virtual networks. I picked two regions which are geo-paired regions for this example, West US and East US. West US is primary in this case and secondary is in the East US Azure region. So first important step here is to establish a channel of communication between those two virtual networks. And basically that's the biggest difference in Failover Groups between Azure SQL Database and Managed Instance. In Azure SQL Database, thanks to the fact that your SQL databases are available through the public endpoints, they can be connected automatically through the Azure backbone. However, with managed instance, your instances are injected into your private IP address space within your own virtual network. So basically, there is no magic to make a connection channel between those two without you actually creating this channel. There are different options available here. So one of the options frequently used are VPN gateways. So you would create a VPN gateway on both sides and then establish communication between those two. Now, there are certain scenarios and network configurations where this is not possible. For example, if you are using sometimes of the hub-spoke architecture and some of your virtual networks are already using remote gateway, there is no way basically to, in addition, have that they can have their own VPN gateway. So in these situations, you can go with different approaches. For example, you can leverage your existing express route connection and basically use your on-premise part of the network stack to establish communication channel between those two regions. Now, it's completely under your control this way. On the other hand, you're basically spending part of the bandwidth of your express route for this replication traffic between instances. So be careful when deciding about the dimensions of your express route in this scenario. So there is a third scenario also that became available very recently. So we announced this last week at Ignite conference. So it's global VNet peering. It's known concept from the Azure networking. However, it wasn't available previously for Azure SQL managed instance. Now you can use global VNet peering to very simply connect your two regions and establish this communication channel needed for failover groups. So what would be the next step? Of course, you would create subnets for your MIs on both sides. And of course, those subnets should have these network security groups with the inbound and outbound security rules so that you can basically configure what kind of traffic can go out and can go in. There is a set of requirements with the failover groups. So basically you have to configure port 5022 and the port range between 11,000 and 11,999 in order for this geo-replication within the failover group to work. Okay, so what's the next step? So we are creating now first instance. It's going to be a future primary. Of course, this instance comes with its fully qualified domain name. Now note the part of the fully qualified domain name right after the instance name. It's so-called DNS zone. DNS zone is a unique ID that's being generated with the first instance within a subnet. Together with this DNS zone, there is also a multi-domain SAN certificate generated. With this certificate, client applications basically can establish connections to any instance within the same DNS zone. So now we are coming to the first critical step. You are creating now an instance future geosecondary on your second geosecondary region, but basically you have to reference your primary instance as its primary in order for this secondary instance to inherit DNS zone from its primary. As mentioned, that will help these client connections using multi-domain certificate to transparently connect to either of those two instances before and after the failover. So now you have your two instances. You can connect to one or to the another. However, there is still no geo-replication established. Once you create failover group, data starts to flow from instance 1 to instance 2. First, during the phase of so-called seeding, where the existing data is going to be transferred to the geosecondary, and then after that, this process enters so-called catch-up phase. This is the standard phase or regular phase in this process, and all the time during the replication, it will stay in this catch-up phase. Now, what's next? You could still connect to your instances using your fully qualified domain names of the primary and secondary instance. However, instead of that, you should leverage so-called listener endpoints. So basically, there is read-write and read-only endpoint listener created at the same time when failover group is created. This way, your client applications can transparently connect to the primary at each moment, regardless of the failovers. Thanks to that, you don't have to change anything in your connection string. Bear in mind, though, that there is so-called time to live, or there is a period of time during which DNS records are being cached on the client side. So until this cache expires, existing connections will not be able to connect to the new primary. However, any newly established connections will go directly to the primary. We are not talking about the pooled connections here, of course. Once you established first failover group, you can now, of course, create more instances in both of these regions, and you like order of creating those instances is not relevant anymore. You can create instance 3 and instance 4 or vice versa. So basically, these instances, since they are sharing the same subnet with the existing instances, will simply inherit this DNS zone from first instances. And then you can, of course, create another failover group between those and leverage these endpoint listeners, both read-write and read-only for this new pair. So let's pause for a moment here and do a quick recap. So what we learned so far. So instances in failover group must have same DNS zone. You are the one creating connection, establishing connection channel between the VNets for failover group to work for managed instance. Instead of using fully qualified domain names of your current primary and secondary instance, it's strongly suggested to use listener endpoints. And of course, be aware of this client DNS cache refresh time involved for the existing pooled connections. Okay, let's continue with some interesting cases. So as we already mentioned, system databases are not replicated to the secondary. So what does this actually mean? There are certain types of instance level objects that you still need on the secondary side, and you should replicate them. The good thing and good news is that you can actually replicate them manually in most of the cases. So agent jobs from the MSDB logins, you can of course create all of them on the secondary explicitly, even though it's read-only replica, but your system databases are not being replicated, so they are in read-write mode, so you can create those objects without any problem on your secondary instance. When creating logins, please make sure that you specify security identifier or seed, same one as it was on the primary, so that you don't have any problems in any scenarios on the SQL Server going forward after the failover. However, there are types of the objects like service master key that cannot be copied to the secondary. And service master key is important part of the higher encryption hierarchy on the SQL Server and SQL managed instance. So basically, service master key encrypts database master key, which in turn encrypts all the database scoped certificates, keys, and similar things. So basically, what you can do here now to be able to open all of these encrypted things, encrypted by the database managed key on the secondary instance. So the good thing is that database master key is being protected not just by the service master key, but at the same time it's being protected by the password. So basically there is a mandatory password that you need to specify when you explicitly create your database master key. So it's going to help in this case. So you know your database master key's password, so you can call sp-control db master key password store procedure on your geosecondary and add that password to the credential store on the secondary side. Now, since there is this password available to your system, first time that on geosecondary after the failover, system tries to open and read the encrypted master key, it will try with the local service master key. It won't help. It won't succeed. However, thanks to the stored credential, meaning password that you just transferred from the primary, it will be able to use that credential and open the database master key. Bear in mind that you should do this, meaning provide the database master key's password on the secondary side as soon as possible. So don't wait failover to happen. After failover, it's going to be too late. So as soon as database is being created and replicated to the secondary, if you have any scenario involving master key or anything protected by the master key, make sure to basically provide this password on the secondary side. So what if you don't have this password? So there are solutions, there are third-party applications, or even SSIS integration runtime, creating database and specifying password automatically so you don't have access to that password. Good thing is that you can have additional password, your password, that can protect the same database key. In this case, you would basically call alter master key add encryption by password command on the primary, add your own password, and then call store procedure from the previous step to provide the same password on the geosecondary. Let's talk quickly about transparent data encryption in failover group scenarios. So there are two flavors of TD: service managed, where all management of the keys or certificate protecting the data at rest is on the system, and platform takes care of everything in this case, so you don't have to worry about anything. However, if for compliance or any other reasons you're using customer managed TD or customer managed key BOIOK or bring your own key scenario, there are certain important things that you should be aware of. So both key vaults on the primary region and on the secondary region should have completely the same set of the properties and the same access rights, so that there are no bad surprises after the failover. Also, in both AKVs, you need to have completely the same key material, not just the current TD protector, but also historical previous protectors. Why is that so? So imagine that you, after failover, have to perform point-in-time restore for one of your previous databases, for example, to the state 30 days in the past. And what if you rotated your key like 15 days ago? So basically, in order to be able to perform point-in-time restore, you need to have access to the previous key as well, not just to the current key, in order to perform this point-in-time restore operation successfully. And then another important point: if you are during the initial setup, or if you are doing a rotation of the TD protector key, make sure that you are doing this action on the secondary side first. So as you can see, there are at least two cases where you can affect health of the failover group. One is while rotating the keys in the customer managed TD scenario, and then the other case is if you are leveraging your on-premises networking infrastructure and you can unintentionally break connectivity on some of the firewalls in your network and basically blocking the replication between the instances in the failover group. So if you have any of these cases, it's strongly advised to keep an eye on the health of the failover group replication. So how can you do that? You can use system views, DMVs, or you can use monitoring solutions. One of those monitoring solutions would be SCOM. We recently GA'd SCOM management pack for managed instance with support for monitoring of the failover groups. Let's quickly go through the demo of SCOM monitoring of the geo replication. I am now in SCOM, System Center Operations Manager, and there are three things related to the geo failover groups that I want to show you. First, if I go to database engines, I have a list of discovered instances, and here I have a pair of instances within a failover group. One of them is primary and another one is secondary. If I go to the list of the databases and filter down to the databases from this specific server, I can double click it and see a list of all monitors, and within availability I can see new monitor for a geo replication status with 3 different states, and this one is currently healthy. Also, within databases, if I go to the performance view, I can also see new counter related to the geo replication lag, and basically monitor it, set the thresholds, and even create alerts. Okay, we are close to the end of the presentation, so another round of takeaways and quick recap. So please mind that system databases are not replicated, and make sure that critical objects from the system databases are replicated by you. Also, there are cases where you can affect failover group health, so make sure to be aware of that and keep an eye on the health of the failover group replication in these cases, and of course perform regular DR drills. That's the only way to make sure that you will avoid bad surprises once a real failover happens. That would be all. Thank you for joining, and I hope to see you again at SQL Beats 2021, hopefully in the UK. Cheers!